Hello everybody. So this is the first lecture where we will show a concrete case step by step. And this lecture, this is about the reification and the delegation. So basically this is how did we integrate it inside Pillar, a new object so that we could have more modularity inside Pillar. So this is a case study. We will show you the step by step what we did so that we could get Microdown, which is a markup language, into the Pillar compilation chain. So the goal here, this is to show you with a concrete case how the fact that you have specific object or dedicated object can support delegation, and that delegation creates dispatch space. So this means that suddenly I will avoid to have conditional, but just send message to the right object. You will see that again in the strategy design pattern later in the MOOC. We will already study a concrete case, the way Pillar was changed to introduce the support for Microdown format, and also how can we do it modularly. Pillar, this is basically a document compilation chain. It means it produces MOOCs slides like the one that you see on the screen and websites. So Pillar use a .pillar file containing Pillar text. So Pillar, this is the name of the compilation chain, but this is also the name of the markup language. This is a null markup language that we want to remove and use Markdown instead, but we want to do that step by step so that we can still use Pillar to produce document and slowly use also Microdown to produce the same document. So in fact, we got a new requirement, and this is like in real life. So Pillar should handle Markdown files containing Microdown text. And the challenge was, okay, how do we support this new requirement? And how do we do it step by step without breaking the system? So that's also something important. This change evolved over a month or two, and we didn't want it to break everything. Let me show you how Pillar manages the file. So basically, Pillar will get as input a document with some Markdown, and then it will ask a parser, and the parser will convert this input file into a tree of objects. So here you will have, for example, a header, a text, and so on. So you have a tree, here this is a tree of objects. So how this is done, okay, we ask the parser to parse the input. In fact, in Pillar, there are several parsers, and there is one in particular that is called PR parser. And now how this is done, this is that there is one parser, because at that time there was only one syntax, associated with the class PR document. This is what we see here. When we want to parse an input, we request the class, okay, class, can you give me the parser? And we send the message parser file with the file as reference. So in this version, it was already good because it avoids to hardcode the parser everywhere in the code. We only got one single entry point to access the parser. This approach worked when we wanted to substitute different versions of the parsers that we have to check if they are more robust or have different properties like speed and things like that. This was nice because we had only one single place to change. Now the problem is that if we want to have another format, it does not work anymore. So you see, so if we look in the build chain, so I don't want to go into detail, but in the output document, so this means to produce something, we have a built-on. What we will do is that we will have a parse expression. Then after we will transform the document, and then we write the code, and then we do post transformation. And this parse input document, this is where we see the expression that I mentioned before. We ask the document class, hey, give me your parser. So basically, this is a global variable that is disguised. You will see that there is also another lecture on singleton and disguised global variable, but this is a typical case. And we parse the file, and then this guy will return a parse document. So it worked, huh? So this is not the problem. This is that when we want to change something, then suddenly we have to pay attention because this is not easy to change. The implication is that there is only one parser. There is only one syntax. It was really good when we had only one syntax, but now we have two syntaxes. So what do we do? This is the problem. And then also the other limits, this is that the check for file extension are hard-coded somewhere in the code. So this means that suddenly, this is not because you provide a MD file that it will be managed correctly, because if the system looks for .pillar file, it will ignore the .md file. In addition, for example, a file does not know its project. So in the project, this is an object that represents how to build it and things like that, and how to access the configuration. So basically, at the end, we could not distinguish between a .pillar and a .md file. And even if we could, we had only one parser. So what is the solution? And we will do this solution step by step. This is, instead of manipulating directly a .pillar file and a .md file and doing the check, what we will do is that we will create an object that represents the input. And this object will know, oh, this is a .pillar file that I should read. Oh, in that case, I should invoke the correct parser. So what we will do is that we will Reify, create an object that has the responsibility to represent what is an input. And each input will know its format and all kinds of things like the parser. And then we will get one parser per input format. So the first step was to introduce the class input document. So instead of manipulating files, we want to manipulate objects. And input document just wrap the files and more information like file extension and parser. This was the code, for example, to identify the file that should be treated. You know, he was checking, okay, I want to check all the children, and I check if this is a file, and if it has a file extension that is called pillar, then and then what we did, we said, okay, in that case here, let's introduce a pillar input document with specifying. So here we create our first implementation of an input document. Like that, suddenly with this change, we don't manipulate any more files, but we manipulate input document. And then naturally, we can say, oh, you are an input document, so now the parser, I don't have to ask it to the PR document class, but to the PR input document. So here, I just put the checks that says, okay, I know this parser, this is PR document parser, and now this is the responsibility of this input document to return the correct parser. And if there is, you see, for the moment, the solution does not fully work because it only manages pillar and is still doing a check that at the end we will remove. But this is, we will do it step by step. So this is what we call a little chicken step. So one of the ideas is that each time we did those changes, we wanted to have always green tests and little modifications so that we can control what we are breaking and do not stay a month with a broken system that said, yeah, yes, tomorrow it will work. No, we wanted every day that at the end of the day, all our tests were green. So what we see is that here we didn't distributed the responsibility first. What you see is that here, we are still doing the checks here and not inside. So the next step will be to move this inside this object. So to support .md files, the compilation chain should accept .md file. It has a different syntax and a different parser. So what we ended up to do, because I want to show you a synthesized version, because else that can be really difficult to follow. At the end, we subclass from this original input document a class that is managing pillar document. And then we did another subclass to manage microdown input document. What you see is that here the methods, this class has two methods. One is called parser class and parse document. So parser class here will say, oh, I want to use the pillar parser, or this is this document parser that we had previously. And the parse document, this is the object that will have the responsibility to invoke the right parser with the file contents. On microdown, we have also the same API. We will have the microdown parser that we will return a parser that knows that, and then it will parse the same, except that here you see there is these little things here is that when we were at this phase of the work, we could not do any treatment on a microdarn files. We had no visitors and nothing. We just wanted to get the microdarn inputs and convert that internally as a pillar internal models. So that's why here what we said, oh, you know, this is easy. We parse with the parser and then we convert. We have a visitor that converts the document model expressed in microdarn in pillar. Now this is not anymore the case because we are further in the migration. But the idea is that this move was the cheapest move to be able to get a different syntax working with all the tools that we had, like different visitors and transformation that I showed at the beginning, the phases. So the idea is that, okay, here we convert a different input into an internal format that is the same as before. But you see, this is the input document of microdarn that is responsible for doing this transformation. When I use a pillar document, I don't do the transformation. So what you see is that basically what we got is that instead of having this parser input file that I show you at the beginning on the output document, then it becomes just, oh, you know, I have an input file. I just ask the file to do the job. And I move this code in the input document object. So I give more responsibility to my object. And this is the same. This is what I show in the UML diagram, is that we can do the same with the what you see is that you have the same input and things like that. So in the UML diagram, I was a bit wrong, but because we have multiple parsers, so here I show that we use the previous parser. So now we add the delegation, the extension checks. We don't want to have a place where we have to do, oh, if this is that, or if this is that, or if this is that. So what we did is that we introduce the responsibility in the pillar input document to manage the extension. And we said, do you deal with this extension? And each of them said, okay, this is the extension I want to deal with. So we could have also includes and said, okay, that you can manage multiple extension. For example, like that, I could say something like, if this is MD or if this is MD includes an extension, and I would get multiple. I would get all this extension managed for the microdarn. But again, what you see is that we pushed this behavior, which was central in a place before, that was in the output document. We push it to the corresponding object, like that. The object has the responsibility, and we are able to dispatch. And we don't make a explicit test. So then we got the following question: what if? So now we could parse MD and pillar format. The question was, okay, now we would like to be able to phase out the pillar version. It is still not the case, but we want to make sure that they are optional. Because like that, suddenly we could say, oh, please do not load this package. And then we don't have the support for pillar. Because this is what we want to do. We don't want to maintain two versions in the long term. So the question was how to make them optional. So how to make them optional? We use a registration mechanism so that every new input document kinds can declare their existence and say, oh, so we define on the peer input document class an input class for a file. And these methods, based on the extension, you see, this is where you see the DAS handle. We could say, okay, in all the subclass of peer document, is there one that will manage the extension of this file? And here we have a null object that we will see in the future lecture. This is a null object pattern that says, oh, by the way, I have no document. So this means that I have no parser. I will raise an error. And like that, we don't have to do a if there and things like that. And we can have different, we can manage the null situation. And what you see is that here, each subclasses, when we load a package, each subclasses of input document will declare and said, oh, I'm available, I'm here. Now, since they all expose the same API, which is DAS handle extension, then they will be we will select the correct one for a given file. Note that this way of doing a registration is based on the reflective API of Pharo, and we can do a better registration. We did it like that in Pillar because it was cheap, but there is better ways to do that, and there is a dedicated lecture for this aspect in the future. So what you see is that at the end, now we can revisit the code of files to be built that I showed at the beginning. And what we do, we said, oh, given a set of files, we just want to create the corresponding, because this method here will return either a PR, a pillar input document, or a PR microdown input document. So depending on the file extension, I will get a given input document. What you should see is that here I can mix MD and .pillar file, because for each file I will get the correct input. So now I can also support the incremental migration of the books that are written in a pillar, and that the author can mix microdown and pillar. So from that perspective, that's a really nice. What you see is that this design really supports well the end user. So to step back, what we did, we turned implicit things into an object. Basically, we were file checking plus parser, and we turned that into an input document object. We specialized this one object because at the beginning there was only one. We specialized this one object into hierarchies. So we went from one single class input document we turn it into an abstract class with microdown and pillar. We define polymorphic behavior in this object. So here you have the same API. They answer the same message. So this means that from the client point of view, here I could call either this one or that one without taking care. So from that perspective, the fact that we created this hierarchy and this object, we created dispatch space. This means that I just send a message and the system will resolve. So if tomorrow I want to alternate syntax, I just have to define a new subclass, which the same API, and that will say, oh, I handle, I don't know, ASCII doc format or TXT or whatever, and plus a parser, and I'm done. And then we use a registration mechanism so that each of these can be unloaded and the system can continue to work, or that we can mix files from different formats. So from that perspective, I think that this is a really nice case study to show that creating an object was making sure that we can suddenly get a modular system and decouple the responsibility. So as a conclusion, what we did is that we define object, we define each object as its own behavior, we delegate to such objects. And this is really important to think. Sometimes if you have a condition, you said, oh, I am writing a condition. The question is, else, do I have an object to which I can send a message? And this is what you have with the tell do not ask. At the beginning, the files were asking the extension and things like that. And at the end, we have this registration mechanism. And the system, we just said, oh, I want to produce that. And the system does it for us. So there is a nice pattern that is in the object-oriented Reengineering patterns book that is called Transform Conditionals. And I really encourage you to read these chapters. The book is available on the web.